Guys ready?
If you want to follow along there, we have a website that is called cometminds.com, and if you scroll down to the bottom, our slide is right there. The surface on Mars is made of sand. It is similar to talcum powder. This sand is very dangerous if it gets into your lungs or any other body part. Our teammate Bryden discovered this after researching about the surface of Mars. Storms. The storms on Mars have very high winds that can blow any unsure item. Our teammate JJ found out the conversion rate for Mars, which was 60 miles an hour on Mars, so that equals a height of 6 miles an hour on Earth. Sols. Days on Mars are very different from Earth days. Sols is what NASA calls days on Mars. A sol on Mars is 39 minutes longer than a day on Earth. A year on Mars is precisely 687 sols. We learned part of this from a scientist at the observatory named Greg Wolver. The atmosphere of Mars's atmosphere. The atmosphere of Mars is 96% CO2, so the oxygen on Mars is 4%. We got this idea from someone talking about if we lived on Mars. A special thanks to Greg Wolver at Ashton Space Observatory for helping us out on our project. Also, he said that there was a rover on Mars that got dust on solar panels, and we said that we had an idea that could solve that problem, and we will show you. Getting power on Mars is a hard task because of solar panels get covered in dust from storms. Power on Mars can come in two forms of energy. One from energy is wind, and others is solar.
Our solution to storms on Mars is to take a fan that is powered by a windmill to blow off the dust on the solar panel.
Since receiving the Global Innovation Award, we have used a fan that blows too many windmills, and they charge two AA batteries, and they power a small fan that blows the dust off solar panel.
Over Christmas break, one of our teammates, Peyton, shared our project with his Uncle Brian, who owns an appliance store. And he said that our one windmill did not give enough energy to power our fan. Also, he said we need a diode to make the windmill charge the battery pack. Finally, he said that we need rechargeable batteries so our windmills can charge our batteries.
Why we picked the fan and windmill we have. We picked this fan because it only needs 3 volts to run, also it was cheap. We picked these 2 windmills because they both would give energy under 6-mile-an-hour wind. Also, they both gave enough to power the fan we have. Finally, the windmill was cheap.
Our batteries. Our windmills produce about 2.9 volts. Our rechargeable batteries are 1.5 each, and it takes 3 volts to run our fan. Here are some examples of our ideas if we had the money to build it full scale. My idea is, so the wind is 6 miles per hour on Mars, which blows the fan, which powers the windmills, to blow the windmills, which powers the fans to spin off the dust on the solar panel.
My idea is to put all the stuff underneath your solar panel and put your fan on top so you don't accidentally step on it.
My idea was just the original one, so I just put all of the ideas that we had together.
My example has all the stuff that we will need in the center. The fans on the outside push it towards the middle, when the fans on the inside push the sand diagonally out.
My idea was to have a square solar panel because they have more space, and then I have what it would look like as a quick little sketch.
Thanks for listening. For information, visit us at cometminds.com.
Would you guys like to do questions first, and then we'll let you pick everything up, or does that work for you guys?
We're going to show.
Oh, gosh, okay, please do.
So these windmills are getting blown by this 6 mile per hour wind, which we used. How we tested what it was with a wind meter, and he will tell you what it is about, what it does. It tells you about how much wind you're using, so you don't waste energy. And then what it does is it blows the thing, making this light power. So this windmill is powering this light. And then we couldn't figure out how to connect this, so what we did was just this. So how we would charge these batteries is with this, plugging this in here, but we'd need to use a diode, which is this, which stops the batteries draining, making that spin. And so when I turn this on, if I use this confetti, which will represent the dust on the solar panel. If I turn this on, it will slowly move it off the solar panel.
This is a voltmeter, and so we use it to see how much the windmills are producing, so we know how much we might need more of or less.
The windmills are giving energy to recharge the batteries, and they're also making it so it could see if the diode would work if it's not reversing.
These batteries are rechargeable batteries, so our windmills, whenever they spin, they will recharge our batteries. And our rechargeable batteries generate 1.5 volts each.
Now, guys, I don't mean to interrupt you. We have just a couple minutes left. You have some more to finish, or can we ask you some questions?
Questions?
So what research did you guys maybe do on solar power and wind power? Because you guys are doing a great job harnessing the wind power. And I was wondering if you guys looked into just using wind power to power maybe your habitat.
We didn't really just look into wind, but mostly we did. But we also had our solar, which we didn't really worry about the most because our next source of energy was probably wind.
It sounds like you guys did a lot of improvements as you went along and stuff, and that's fantastic. If you were to keep going from here, do you guys have any ideas about what you might be doing next? About what improvements or things you need to, what direction you go, or anything